Okay, so here is our crankshaft in our setup. We're going to press apart the crankshaft, get all the bearings, seals off of here to be replaced. And I've done this several times and posted some pictures, but thought I would just videotape the process if anyone's interested. They say you need a really heavy-duty shop press, which is probably true, which I don't have. But what I do have here is a pretty heavy log splitter. And believe it or not, it works. I've done this before on several of these, and it's really pretty easy. One key thing is that none of the parts of the shaft, which is your counterweights here, which are clearly, everything is 180 degrees on this twin, and the gear timing is critical for the counterbalance shaft. If you're doing a Rotax, it would be critical for the rotary valve, and nothing's keyed. So angular position of all of this way has to be maintained. You can mark everything first, which I do, but what is key is if you mark it real good, I think you'll be fine. But if for any reason you lose the original position, you're going to have to re-inspect this, and you really need a lathe for that, which I have, and I have done that. Especially if you need to replace either of the crank pins. The new ones won't have a mark, right? So you're stuck with having to re-inspect and realign the angular position of all of this. And this gear, obviously, it has a mark so that it can be aligned to the counterbalance shaft properly, but there is no key or indexing of the gear to the shaft. So without properly marking that, you're going to lose that position, and it has to go back in the original position for your original index mark to be properly aligned with the counterbalance shaft. And I have reestablished this alignment, which is I don't remember, but the gear, the center line of one of the gear teeth with that mark is aligned on the 90 degree, either this way or this way. I don't remember, but it is aligned with the principal axis of the main shaft. But again, you'd need a lathe with some dial gauges to reestablish that. I'm not going to get into that, but when we're done, we will inspect this, because what we'll inspect is runout. And the spec from the factory is the runout to, this is your main axis right here, which is on the portion of the shaft that is solidly connected. It's cast or forged into this counterbalance weight right here. So this will all be original, and the ends of the main, they can be out of position based on the alignment you get with the outside counterweights here and here through that crank pin. So when you're all done, you have to inspect these mains here at the ends to the center main. I will show you that because that's critical. And the spec from the factory, it's in the manual, is 1/1000th indicator run out here at the magneto end, and 2/1000th at the PTO end. And using these pretty crude methods, I have always been able to meet that. But like I said, that does require a lathe or a pretty good inspection setup to check that. And possibly I'll show you that at the end. Okay, here's our setup to remove the outer bearings. These aren't too hard to get off. You can use this bearing puller tool to get them separated, and then a regular gear puller to grab them and pull those off. But it's a lot easier with the press, and so what I'm using the bearing separator for is I'm backing up the bearings in my fixture, and then I'm just going to push it through. Okay, so we'll show you that. Okay, so these outer bearings have come off, and as you can see, they're really rusty. They barely turn and they are ruined because of the water that got into the cases. So those are junk. Now the next stage is the crank pin, which is an offset push. And you need to be a little more careful to get a good rigid setup with this, so you don't get bending. You're not going to bend this shaft, believe me. The materials are really tough, but you don't want to get anything popping out of your setup, flying out of there. You know, wear your safety glasses, and everything will go smoothly. All right, this is the setup for pushing the this outer counterweight off, and we're going to actually push the crank pin through. So we have some rather sturdy 3/8 plate to back this up, and we're just going to push with a bar that's the right size. You can see I have my alignment mark, and I like to use a small grinder on a little grinder disc on a Dremel tool. Those marks will not get rubbed off or anything, as you can see. On this setup, it's an offset push, like I said, so the back end of this wants to lift, and I'm just going to hold that down with a pretty sturdy ratchet strap. And another important thing is make sure the connecting rod is not being held up by anything here, because you don't want to bend this as the shaft moves back. And that's all there is to that. Alright, so we've successfully pressed the outer counterweight and portion of the main journal, which is all integral. There's no press there, that's cast all as a unit. As you can see, we got rust built up. We had rust on this journal, which I think made it a little more difficult here to break this free, but once they break free, they just fly apart. This next step is the main, and this is the hardest one. It's a bigger diameter, and it's also a tapered press fit. And to make it even tougher, not only do we have the rust here, but Seadoo uses a Loctite product to, it's made for press fits. I don't remember what it is called or what number it is, but they do talk about it, or they call it out in the manual, and that makes this even tougher. What I have found here with my setup anyway, I have had to put the pressure on it and then smack this weight with a 3-pound sledge to get it to break free. So we're going to try that next. Okay, so there you have it. Success. As with any press, it's quite violent, especially with a tapered fit. When these things spring apart, just wear your safety glasses. And the main problem with this one, not only is it a tapered fit, but the Loctite adhesive, as you can see, there's some of that, the white residual on there. That is the Loctite adhesive, and it really bonds this together. The next thing is to just push this bearing, the gear, and the other center bearing off. This main shaft is integral to this counterweight, kind of like that the outer one. So these can easily be removed with we'll use the press. Obviously it's quicker, gear pullers, things like that. But if you can't get this one off, you can't get to these. Obviously the other two outside bearings push off the same way. And if you want to get to the other connecting rod to replace that bearing, it's another crank pin press, just like the other side. And all of these require a lot less effort than this center one. So okay, so here is our stack up of parts for this 951 crankshaft assembly. I haven't cleaned it up yet, but just wanted to just go over real quick, you know, how many parts we have here accumulated, and a couple things I forgot to mention, so I'll point those out. The outside bearings on both sides, there's a couple things you want to do before you press this apart, but the inner bearing shoulders out, so that's just a press till it seats. The spacing between the two bearings here is key. The manual has a spacer tool that you put in place after you press the first one on, put the spacer in, and that will give you the correct offset. What I do is, I have the dimension recorded from doing this before, but I measure the separation distance between these two bearings before I press them apart. So I don't need the spacer tool. I could make the spacer tool, but if it's the first one you're doing, measure that distance, because you can't go by the lines, because there's a radius or chamfer on the bearing, the inner race, and that line really doesn't that distance will be different than the actual space between them. All of these, the center bearing, both center bearings and the gear have shoulders, so they all just shoulder out. No need to record anything. Okay, there is one more dimension you should take before you start pressing the assembly apart, and that is for the tapered press fit of the inside counterweight on the main portion of the shaft. This is the tapered portion here, and this counterbalance does not bottom out against the shoulder here. This is there's a pretty good relief radius here, you can see, and then there's a little sharp corner here, and then this is the straight cylindrical shaft portion for the small bearing. So this really won't overlap this radius, but there's no there's no shoulder, and this will not come anywhere near this bearing either. As you can see, all of these that I've done have this same distance of this little piece that protrudes beyond this side of the counterbalance once it's properly assembled. And believe me, that's a lot of pressure when you're going in on this taper. And you can actually make a spacer if you want. What I do is I measure this distance between here and here, and I have it from doing this previously, but you could even use a wooden block or something, but I found that not even to be necessary, because when you're pressing this, when it really draws up tight here, what I'll do is put some pressure on it and then just tap this, and you can inch that along as long as you have a good amount of pressure on it until you get that distance that you want. Obviously a block in there would be a simple way to go. And let's see, one other thing I'm going to point out is these factory connecting rods have an oil groove cut into them, you can see, but they only have it on one side. The aftermarket connecting rods that I've bought have an oil groove on both sides. Now, you might want to take a picture or whatever, mark it, but before you disassemble it. But these grooves should face the oil nozzles that are in the case on it's the low side of the crankcase, and this is the mag side. So when this is in the engine, as this rotates around, this groove is going to come right up against that oiler, and that's where it'll get the oil from. So you want to be careful with that. Like I said, take a lot of pictures, take measurements, and read the manual. I actually don't think the manual talks about this oil groove, the position of that. But like I said, just from doing this, this is the original location. Alright, so for the last portion of the video, we're going to show you inspecting of the crankshaft. And this is the check of the runout of the two end portions of the main shaft. This is the PTO end, this is the mag end. And the runout will be checked here and here in relation to the center part of the main shaft here. And the reason I do it now is if you were to install the end bearings, obviously you're going to get support here and that's going to help with your alignment. And that's not what you're looking for. You want the misalignment of these ends in relation to the center part. If you were to install these, what would happen is any run out here will actually cause, you know, some wobble in here, and you won't get an accurate reading. It's probably going to read better than it really is, and you don't want that. This is going to be your absolute worst case. Make sure these bearings are, you know, tap them into the housing so they're good and solid. So when you put your dial gauge here and here, you're going to get a true, accurate reading of runout. I will say that to get to this point where your runout is as good as you can get it, it's going to require adjustment. I've never done one of these that I didn't have to do some tweaking. And I assume in a factory you'd have some fixturing that would align everything perfect, but we don't have that. And what I mean by tweaking is these offset end parts of the two outer counterbalances. When you install these, and you got to hit your mark as good as you can, but you're not going to get them perfect. There's those marks, you can't mark it accurately enough or hit those marks close enough to get perfect runout. Not for 1 or 2 thousandths like we're looking for. So any angular offset here of this counterbalance to this counterbalance is going to show up in that runout. And that's really what you're looking for here. If you did have some bending of any part of this, that's going to show up here, and you'd never be able to correct that. All right, so this is an indication of that too. I've never had a problem with that. Now, if you do need to tweak either of these, it doesn't take much. What you do is you hold the inner counterbalance, and you can tap either end of this counterweight in the direction that you need to go. And I've already done that process, and it's just a repetitious process where you adjust it and indicate it until you get the alignment as perfectly as you can. Now, what I do is I weld, I don't know if you can see it, but then I'll weld the crank pin here. And I know SBT does this because I've rebuilt SBT rebuilds, and they're welded. I think you lose some holding power when you unpress these and repress them, so that's why I do them. Okay, so I'm going to slowly rotate this, and it's really sensitive to even hand pressure. But it's going up to about a little over 2. And that's, you know, when I let go, it's going back to 0, 2, let's see, 2.5 looks like the worst case. When I let go, it's 0, 0. It looks like about 2.5 is the max. Yeah. So you can see it's, you know, very sensitive, but we're getting about 2.5 thousandths. So I'm going to call that good. I think it's really good for this crude setup we have at home here. Okay, here we go on the mag side. about 2, 1. Yeah, it's really sensitive. Going up to about 2 there. So I would say we're about 2 on that side also. And, you know, for our purposes, I'm going to call that good. I think that's pretty good for the setup I have here at home. When you put those end bearings in, that's going to make a big difference too. So I'm not going to worry about that. So I would say we're pretty good. All right, so with that, that concludes this video. If you're thinking about attempting this at home, hopefully this helps you. Thanks.